Okay, let's go ahead and let's do a couple examples. I'm going to do this example with the summary statistics, and then we'll do another example that we have to analyze the data. So that's what my plan is. And if you have the 13th edition of the book, this is on page 406, number 11. So as you can see, we've got coffee machines, and we've taken a random sample of 27 cups. They have the mean of 7.14 ounces and a standard deviation of 0.170 ounces. We're going to use a 5% significance level to test the claim that the machine dispenses amounts with a standard deviation greater than the standard deviation of 0.15 ounces specified in the machine design. So remember, step one is always to do our hypotheses. And our null hypothesis is always a statement of equality. So we're going to say that the standard deviation equals 0.15 ounces. Or we could say the variance equals, and we have to square 0.15, 0.225. Then our alternative hypothesis, they tell us right here, it's a standard deviation greater than what we assume, greater than the design specified standard deviation. So it's greater than 0.15 ounces. Or alternatively, we could say that the variance is greater than 0.225. And those would also have units of ounces. Then 2, we're going to set our alpha. Alpha equals 0.05 because that's what they told us right there. Then 3, we're going to summarize the data. So n is 27. The sample mean is 7.14 ounces. The sample standard deviation is 0.17 ounces. Okay, and then step 4, we're going to do our test. So we're going to talk about, we're going to do chi-squared test of standard deviations or of variance. Okay, and our formula is, and I would recommend you write it down even though you're not going to do the calculations by hand, n minus 1 times s squared over sigma squared. And then we're going to go to statcrunch. So let's do that. So when we're in statcrunch, we're going to go to stat, variance statistics, one sample with summary, and the sample variance. Okay, our sample variance was, what is it, 0.0225? I think so, because we're thinking it's equal to 0.17. Nope. It's going to be 0.17 squared. And that's going to be 0.0289, and our sample size was 27. Now, notice what we have next is we've got our hypothesis test. That's what we want, but we need to change we need to change that number there. So again, we want to put in our 0.15 squared, which is going to be 0.0225. And notice how that filled in for us in our alternative hypothesis. And then we wanted it to be greater than, so we're going to do that. And then we're simply going to do compute. Okay, so now we have our result. I'm going to snip my results using my snipping tool. And let me move it out of the way here. I want new, and then I'm just going to snip that options box. I'm going to copy it, and then I'm going to go back to my whiteboard and I'm going to paste it in there. Now when you're doing this, I would assume you're going to do it on paper or in a Word document. If you're working in a Word document and you want to do the equation, use the equation editor. It's not that difficult, but you might want to practice. I'm going to go ahead and paste that in. Oh, that is not what I wanted to paste. Man. So let's get rid of that. Let's get rid of this. Let's go back to my snip. Make sure that I copied it. There. I want to copy. Now let's see if I can take it back. And I want to paste. It's not working. I don't like when that happens. So let's get rid of it. Go back to my snip. I'm going to do File, Copy. See if it works now. I'll try it as a picture. Well, it doesn't like that. All right, so I'm going to save it as and I'm going to just do chi-squared here. I don't like this. And now let's go back to the whiteboard. We'll get rid of that again. Let me paste in a picture. I was in my pictures, and there's my chi-squared. So now I have my results there, and I'm going to just make that a little bit bigger so that I can actually see it. Okay. So now let's look at what's happening. I have an extremely small p-value. So let me go back that I know my p-value is less than alpha. So that means, and 3 dots in math means therefore this is statistically significant. So when something's statistically significant, I have evidence against my null hypothesis. So I can reject my null hypothesis. And that's all that ever goes in step 5. Step 6 is going to be my summary. These data strongly suggest, because my p-value is very small, that the machine standard deviation is greater than 0.15 ounces specified in the machine design. Okay, and now I got an awful lot of that. Let me do a highlighter here. I got an awful lot of that phrasing right out of the problem. So there's my 6-step test. Okay. So what we're going to do now is we're going to look at number 15, which again, if you have the 13th edition, is on page 406. And we're going to look at drive-through service time in seconds at McDonald's during dinner times, and then also at Wendy's. We're going to assume that dinner service times at Wendy's have a standard deviation of 55.93 seconds. We're going to use a 0.01 significance level to claim that the service times at McDonald's have the same variation as at Wendy's, and we're going to talk about should we take any action. So let's look at that, and I'm going to pull up the data set. We're going to do it with the entire data set. So let's look at that. And so I'm going to go to statcrunch. And when we use a data set from our textbook, we use this link right here. And I want to do data set fast food. And you can see I have all kinds of stuff here. So let's read what this says. Oh man. I want to see what these things are. McDonald's lunch, and I bet that's McDonald's dinner. Let's just make it bigger so we can see. Yep. So we want to deal with this second column. I want to go stat. Again, I'm going to do variance statistics, one sample, but this time it's with data. And I want to do McDonald's dinner. And again, I want to look to see what this should be. So I have my columns that I want to do. I need to do my hypothesis test. What we're looking at to see if it's the same thing as Wendy's, and Wendy's is 55.93, but we have to square that because that's a standard deviation. So we want to put in we want to put in 3,128.1649. Okay, and it says test the claim that they have the same variation. Okay, so that just means it's either equal or not equal to, so we're good on our alternative hypothesis. So let's go ahead and let's compute, and let's see what we get. So here we get our sample variance, our degrees of freedom, because we had 50 individuals in our data set. You get their chi-square statistic, and there's our p-value. So let's go ahead and let's snip this. I'm going to try something here. I'm going to copy it, and I'm going to close this. Man, going to close this. I'm going to say no. I'm going to pull up my whiteboard. And I'm going to paste this in here just so that that's all done. Okay. So there's my data set. So let's get started. So I'm going to start with my hypotheses. Always, step one is starting with your hypotheses. So my null hypothesis is that the standard deviation for McDonald's is the same for the standard deviation of Wendy's, which is 55.93 seconds. And then my alternative hypothesis is that they are not equal. This is a two-tailed test. And it's one sample. Step two, I'm going to put in my alpha level is 0.01. And step three, I can go ahead and I could summarize my data. I had 25. We did not do descriptive statistics, so I'm just going to pull in my, I can find it, I'm just going to pull in my data from statcrunch. Step four, I'm going to do a chi-square test. And my formula for my chi-square test is going to be, I'll do it over here, chi-squared equals n minus 1 times s squared over sigma squared. And we get our chi-squared statistic equals 62.05. Our p-value is 0.19. So our p-value, if it was less than alpha, it'd be statistically significant, but it's not. So I always use the less than so I don't get myself mixed up. So the p-value is not less than alpha, therefore this is not statistically significant. When something's not statistically significant, my step 5 is going to say fail to reject my null hypothesis. So step 6 is these data suggest that McDonald's standard deviation of service times is not different from Wendy's. And should McDonald's take any action? Okay, that's not going to be part of our 6-step test, but to summarize that, I think we would say it doesn't look like McDonald's needs to take any action. So when you have this and there's another question besides your significance test, you need to address that separately. So I hope this helps how to work through testing a claim with standard deviations.